5.2, verifying trig identities. What we should learn? We should learn how to verify trig identities. Verifying trig identities basically means you want to verify that this guy equals this guy. Now there's some rules. First rule, you cannot do the same thing to both sides. If there's like a wall here, you can do something on this side or you can do something on this side. You want to make them match. You can't multiply both sides by a number. You can't add a number to both sides. If there's a wall here, work on one side or the other. Now you can work a little bit on each side if you want, like do a little bit here, do a little bit there, but you cannot do the same thing both sides. That's the number one rule. You have to verify that this works. You can't assume it works. And there's some other tricks here. Work on one side of the equation at a time. Usually you want to start on the side, this is very important, that's more complicated. Start on the most complicated side. That's usually easier to do. This gives you something to work with. You always want to look for opportunities to factor expression or add common denominators or square binomial or create the same denominator. Look for opportunities to use fundamental identities. That just means like Pythagorean identity, tan equals sine over cosine. Like here you can use a lot of 1 minus sine squared equals 1 minus cosine squared. Cosine squared equals 1 minus sine squared. Remember, it's secant squared is 1 plus tan squared. Remember, because it's always tans get the plus 1 and the cos go together. Cosecant squared goes with 1 plus cotan squared. That's what they mean by fundamental identities. And now I would also throw in like tan is sine over cosine. You can use that a lot. Cotan is a reciprocal of that. When the preceding guidance does not help, try to convert all terms to sine and cosine. That's one of the things I use a lot. This is kind of a last step. You want to try to use this because these ways are faster. But if you're stuck, just change everything to sine and cosine and then simplify it. And usually it should work out. It might be a lot of work, but it should work out. And always try something. We'll talk about some other rules also. I would say here's a tip. If you have 1 over sine x and you don't like working with fractions, because who does? You can always flip it to the top and change it. It's a reciprocal function. This becomes cosecant x on top. We mostly go the opposite way. If I give you sine, it's going to be 1 over cosecant squared. Going the reverse way helps a lot. If you have sine on the bottom, it makes cosecant on top. Or if you have cotan on the bottom, it makes that tan on top. If you have something in the denominator, you want to move it to the top, you flip it. You change it to reciprocal function. Also, put up here, a function times its reciprocal function cancel each other out, and you get 1. If you have sine times cosecant, cosine times secant, and tan times cotan, those guys cancel each other out, and you get 1 every single time. So they're reciprocal functions of each other, though will cancel each other out. With all that in mind, those are some tricks, those are hints. We're just going to do some problems. Look at this one. We're going to verify this identity. There's always lots of ways to verify identity. There's multiple ways to go around to verify them. Everybody does it kind of differently. If I look at this one, I'm going to probably do a little unusual because I know sine squared is 1 minus cosine squared. Let's say I just work with that side. I'm going to work on this side first. I know I say I always work with the more complicated side, but I'm going somewhere with this. If you look at this, is all secant. I was like, oh, I could change these to cosine. I could do something where I make these cosine. They might match. But I changed sine squared to 1 minus cosine squared, because that's what sine squared equals. That's one of the main rules you want to remember. So anytime you have like this is 2 things, this is 1 thing, you have to break this up. That's what I'm going to do next. I'm going to break this up. I'm going to go secant squared over secant squared minus 1 over secant squared theta. I'm going to break it up since it's a fraction. I'm going to put this over that and then this over that. Separate it out. Secant over secant is 1. And then 1 over secant squared, it's a reciprocal. Bring it to the top, it makes a cosine, like I said here. If it's on the bottom, bring it to the top, it flips. So even if it's squared, just bring the square with it. This becomes cosine squared. And they match. Now, if you want to do this a little more professionally, you would skip the step here, go back, and then you go, okay, this equals sine squared. And then you bring this all the way down. Hey, so now they exactly match. You only work with one side. But there's no harm in working on both sides. I was just saying, like, if you wanted to work on only one side, you could have done this, and then you could have done like, hey, this equals sine squared. In this case, I've worked on both sides a little bit. That's the first one. All you're trying to do is make them match. Here's the next one. So here, we're trying to make this guy look like this guy. I'm going to work on the more complicated side by far. This one kind of has the opposite problem. I have 2 things here. I have 1 thing here. I'm going to want to combine these, which means I need a common denominator. This is 1 minus sine. This is 1 plus sine. This guy's missing the 1 minus sine. Multiply both top and bottom by 1 minus sine alpha. That's an alpha there, Greek letter. And I'm going to multiply this guy by 1 plus sine alpha. So whatever we do at the top, we got to do to the bottom. Over here, we're going to get 1 plus sine alpha over, if you multiply these 2, you could figure it out. It's a difference of 2 squares. So you're going to get 1 minus sine squared alpha. And then up here, you're going to get 1 minus sine alpha over 1 minus sine squared alpha. Same idea, difference of 2 squares. And really, I took an extra step. You don't have to do this step. A lot of people just combine it straight. When you do this, you can combine it because they're going to have the same denominator. You could just go straight to this step. 1 minus sine alpha plus 1 plus sine alpha plus 1 minus sine alpha all over 1 minus sine squared alpha. Again, a lot of times you can just skip this step, go straight from here to there if you want. And now look what happens. Sine alpha and negative sine alpha cancel out. You have 1 plus 1 is 2. And you're like, wait, that doesn't match this, guys. It's only secant. Remember what 1 minus sine squared is? That is cosine squared. And if you have moved cosine, I ran out of space here. But if you move cosine to the top, let me make this a little bit smaller. I could fit it all in there. Okay, like that. I get 1 minus sine squared is cosine squared. And now, if I want to make it match exactly, I can move cosine to the top. And that becomes secant squared. 2 secant squared x. Like that. But keep in mind, I do look for the work on these. These are not ones where you can just put the answer. You're like, oh, this guy does equal this guy, and skip all this. No, no, no. The answer here is all the work. There's that one. This verifying trig identity. For me, these are like a little more straightforward. What are you going to do here? Multiply these. That's what they're trying to get you to do. I could work on this side if I want to. Like I can make with this tan squared equal. But they want you to multiply these two. So let's multiply these two. Distribute, I get tan squared x cosine squared x minus tan squared x. That's that all taken care of. And then this side, I get cosine squared. Oops, I should do the first. Yeah, I'm good. Cosine squared x minus 1. That's what equals. I have this. Then you might be like, what do I do next? Well, here I have tan x cosine x. What I'm going to do is I'm going to change tan. Tan is the same thing as sine over cosine. Sine squared x over cosine squared x. This is still cosine. Remember, anytime it's by itself, like there's no fraction, you can always put over 1 if it makes you feel better. Minus tan squared x plus cosine squared x minus 1. On this side here, these two cancel each other out. And I get sine squared x minus tan squared x plus cosine squared x minus 1. And for a second, I'm looking at this, I'm kind of stumped, like, where do I go next? Because I got to get negative tan squared. And then I kind of see it right here. Sine squared plus cosine squared. Let me rearrange it again, because I'm teaching, I'm showing lots of steps. Sine squared x plus cosine squared x. Let's put minus tan squared minus 1. I just rearranged it. You don't have to, you could do it straight from there. I just wanted to show you. Remember this, sine squared plus cosine squared is 1. That's our next line. 1 minus tan squared x minus 1. 1 minus 1 here, cancel each other out. And you just put negative tan squared x. There we go. I always put an arrow. You don't have to. You just put an equal sign, but I like to show like all that work gets there. That was like a long one. I distribute it out. I did literally just change tan to sine over cosine. Those canceled. I got to here and like, oh, what do I do next? And I was like, wait. I have a positive sine and positive cosine. When you add those two together, it's positive sine squared, positive cosine squared. You get 1. So then that made it all work out. Okay, the next one, we have tan plus cotan equals secant times cosine. So this is one where nothing squared. I have nothing to work with. I would do what it says here. I would change everything to sine and cosine. I might work on both sides a little bit here. Tan is sine x over cosine x. And cotan is a reciprocal, cosine x over sine x. Over here, just for the sake of it, I'll change that to 1 over sine cosine x. I know my math. And I'll change that to 1 over sine x. Right, it works a little bit on both sides. Now again, same problem. This is one thing. I mean, it looks like 2 because they're being multiplied, but you're multiplying. It's one thing. Here's 2 things, the plus signs in the middle. I'm going to try to make this, I'm going to combine this to make it one thing. We need a common denominator. This has a cosine on the bottom, it's missing the sine, so we're going to times by sine over sine. And this side is missing the cosine on the bottom, so we're going to multiply by cosine over cosine. I'm going to skip that middle step and just combine it. So we have sine squared x plus cosine squared x. On the bottom we have sine of x, cosine x. For this left side here. And then the same thing with sine squared plus cosine squared. That is 1. So we have 1 over sine of x, cosine x. And that does equal 1 over cosine x sine x. Again, if I'll make it a little pretty, you can say, hey, this is secant, cosecant. That'll make this, I'll match with that exactly. Would actually be cosecant and secant. But there we go. They match. Let's see. Verify this trig identity. I would say, I look at it the same way. I'm like, wait, this is 2 things. This is 1 thing. This is all cosine and sine. I'll probably work on the left side here. Secant is 1 over cosine. Tan is sine over cosine. And we're going to add them up. I get 1 plus sine of x over cosine x. And they don't match. What we do next is, I would actually work on this side. I'm going to do, notice how this is 1 plus sine, that's 1 minus sine. We're going to use that trick, I think we did last video, which is, we're going to do a minus b times a plus b to get a squared minus b squared. Over here, I'm going to multiply both top and bottom by the conjugate. That's our conjugate trick to get 1 plus sine of x both top and bottom. Because I need a 1 plus sine x on this side. But let's multiply both top and bottom by 1 plus sine of x. And I'm going to not distribute. I'm just going to keep this separate. We're going to get cosine x 1 plus sine of x. On the bottom here, the reason I'm keeping it separate and not distributing, because look at this side. It's just 1 plus sine x. I want this cosine x to cancel. I'm not going to distribute. I'm just keep it separate. On the bottom here, 1 minus sine times 1 plus sine is the difference of two squares. It's 1 minus sine squared. And you're like, that looks nothing like that still. But 1 minus sine squared, we know what that is. That is cosine squared. I'm going to rewrite everything. We have cosine x 1 plus sine of x all over cosine squared x. There you go. This means we have two cosines on the bottom. Well, not anymore. Now we only have one on the bottom. And they match. 1 plus sine of x over cosine x. Again, there's lots of ways to do it. I could have started on this side and got to here and then separated it. Like if you wanted to make it match this guy exactly, I could have done all this, got to here, and then separated it. That did 1 over cosine plus sine over cosine. And then that's the same thing as secant. That's the same thing as tan. Lots of ways to do this. That's the way I did. I worked a little bit on both sides, but you could also do it only working on one side. Working with each side separately. This one looks disgusting, but let's go. But I tell you, I had to think about this one for a second. I was like, what's the best way to approach it? And I think I'm going to go the fact that this right here is squared. We're going to use the identity. Remember, the identity is cos go together. So it's cosecant squared equals 1 plus cotan squared. Right? And then tans are always plus 1. Remember, this only works when it's squared. Cosecant squared equals 1 plus cotan squared. I want cotan by itself. We're going to subtract the 1 over. I'm going to get cosecant squared x minus 1 equals cotan squared. Now, if you can memorize this, all these ones, then you're great. Right? Sometimes I just memorize this and then move it the way I want it. I'm going to change this to this. I'm going to get cosecant squared x minus 1 over 1 plus cosecant x. I guess it should be theta. There we go. Equals. Now you're like, that doesn't really do anything. Well, it actually does. I could factor this top. This is the difference of two squares. So I'm going to factor this guy. And that's going to become cosecant theta minus 1 and cosecant theta plus 1. Let me rewrite it real quick. All over 1 plus cosecant theta. Well, cosecant plus 1 and 1 plus cosecant are the same thing. These are canceled. And I'm left with just cosecant theta minus 1. And that's pretty much as far as I could go on the left side. I mean, I can make that 1 over sine, but it's not really going to help me. That's pretty much as far as I could get there. It's not square. I can't do any of this stuff. It's stuck there. So let's work on this side. I'm going to introduce, we're going to use that trick I like. This is not a fraction. Why do we have a fraction here? Let's get rid of the fraction. I'm going to move this to the top and make it a cosecant. When you move it to the top, it switches to its reciprocal function. So let me rewrite it. This is the same thing as 1 minus sine theta cosecant theta, like that. It's tougher because it's 1 plus, so it doesn't switch to 1 plus sine. It has to stay the way it is. With this, you generally either multiply by the conjugate, or you try to work a fraction to take a factor. This one's by itself, so I can just move it to the top. And then what I do now is I distribute. So I'm going to have cosecant theta minus sine theta cosecant theta. Now we're going to use another trick I talked about. You have sine times its reciprocal, sine times cosecant. Those cancel each other out. You just get a 1, and there you go. They match. So lots of tricks in that one. I had to use this angle identity here to replace that to there. Then I had to factor difference. Here I use one of my favorite tricks is if I don't like fractions, I just move the bottom when it's a mononomial, when it's by itself, I just move the bottom to the top, switch it, and then I could distribute, and then when you multiply something by its reciprocal, they cancel out. Okay, last one. Verify this identity. I have tan to the fourth here, and then all this. Probably not going to work on this side. I'm going to work on this side. First thing I notice, there's a tan on both sides. Let's factor it out. Tan squared x, and I'm left with secant squared x minus 1. Well, if you notice, everything's a tan. That's a tan, this is a tan, that's something that's not a tan. Could we do something with this? And the answer is yeah. Remember the rule? We kind of used a similar one earlier. It's tans plus 1, and the cos go together. So it's secant squared goes with 1 plus tan squared x. The same thing we did here. It's always tans plus 1, and the cos go together. So it's cosecant with cotan. So it's tan squared plus 1 equals secant squared. But I need it to look like this. So let's subtract the 1 from both sides, and we have secant squared x minus 1 equals tan squared. So that's what I'm going to replace this with, tan squared. So I get tan squared x times tan squared x, which gets me tan to the fourth x. And that's it for this lesson.